Don't worry. Calculus is not as difficult as imagined. The simplest understanding of calculus is integral of velocity equal displacement distance. Velocity equal derivative. Displacement equal integral. 90% of the applications of calculus are to physical changes. At that time, Lord Newton created calculus based on physical motion. Let us learn about calculus, starting from the free fall of an apple. Like an apple falling freely. Velocity v equal gm multiplied t. At this time the velocity changes with t. That is, at time t, the velocity value equal gm multiplied t g equal 9.8. Then the apple's velocity v equal gm multiplied t. The velocity changes. So how to find the displacement? Because the velocity changes with t at this time. It is changing all the time. Therefore, when calculating the displacement distance, the logic of displacement equal velocity multiplied time cannot be used. In this case, how to obtain the displacement of apple in the 0 to t time period? At this time it is calculus' turn to appear. It can according to the velocity function v equal gm multiplied t, and find the corresponding position function pt equal gm multiplied done half multiplied t square. Apple's displacement in 0 to t time period equal position at time t pt plus positio and at time 0 p0. Calculus provides the corresponding logic of position function and velocity function. Because the velocity at this time is a velocity that changes with t, it no longer applies to the logic of displacement equal velocity multiplied time. To put it simply, if the speed remains unchanged, then the displacement distance can be calculated by displacement equals speed multiplied time. If speed changes with t, then find the displacement. It depends on the corresponding logic of speed function and position function. Displacement at time 0 to t equal position at time t pt plus positio and at time 0 p0. In other words, in calculus form 0t velocity dt equal pt plus p0. That is to say, calculus provides corresponding logic for velocity function and position function. In terms of physical changes, displacement is the change value. Velocity is the change velocity. So in terms of physical changes, calculus provides the corresponding logic of change velocity function and change value function. The essence is that physical changes are continuous and regular changes. Let us take a look at the mathematical form of calculus. With velocity v, the displacement in the 0 to t time period equal the integral 0 to t v equal pt plus b0. With velocity v, the displacement in the time period at 2b
equal the integral v the dt equal p plus pb.
v equal gm multiplied t. Then pt equal gm multiplied done half multiplied t square. Pi equal gm multiplied done half multiplied a square. The mathematical form is actually very simple. Logically speaking, gm multiplied t and gm multiplied dx are essentially the same. So there is no difference between ft and fx. Let us look at the geometric expression of calculus. View integrals from geometric diagrams. That is the integral x squared dx equal or ed area s equal fx plus f0. The derivative of this area s derivat ive equal x squared. Simply put, based on the velocity v, find the displacement in the time period 0 plus x. So from here, we can easily understand what calculus is. Geometrically speaking, it is the area under a function. That is the integral x squared dx equal area S equal fb plus fa. The derivative of this area S derivat ive equal x squared. To put it simply, based on the velocity v, find the displacement in the time period at 2b. In view, the union of velocity plot and integral plot. At time t, 0 to t time displacement equal red area sequa L0 t velocity, dt equalp tplusp0. The derivative velocity of area SSDERIVAT, IVE equal velocity, GM multiplied t equal flashing blue line, is the relationship on the integral 0 to tv. So let us look at the entire entire falling process. Treat the velocity as a brush, and the brushed area equals 0 to t displacement equal the integral 0 to tv. Becomes a brush model like this, which makes it easier to understand the original function and derivatives. Because 0 to t time displacement equals 0 t velocity dt equal t time position pt plus 0 time position 0. In calculus logic, the original function y is the position function pt. Derivative of y derivative equal velocity. Displacement y equals 0 ti derivative dt. So the content of calculus in mathematics, simply put, it establishes the corresponding logic between the velocity function and the position function. The essence is the corresponding logic of change velocity and change value in continuous and regular changes. That is, original function equal gm multiplied and half multiplied d square. Then derivative y derivative equal di over dt equal gmu ltiplie dt. And original function equal gm multiplied and half multiplied x square. Then the derivative y derivative equal di over dx equal gmu ltiplie dx. xt there is no difference here. It can be considered that the names are just different. In calculating area in mathematics, can turn the required area into an integral graph like this. Use an e.g. calculus logic. Find the area S. The circle area can be brushed out in this way. Then area on the right side equal the integral 0 plus or 2x equal area of the circle. That is, by turning it into an integral model of calculus, the area of the circle is found. Please see my video for details. Find the area of a circle, find the surface area of the ball. So actually calculus is not difficult. The simplest understanding of calculus is integral of velocity equal displacement distance, velocity equal derivative, displacement equal integral. Thank you for watching. See you next time.